A two-force member is any member that has forces applied only at 2 points. And for that member to be in equilibrium, then we know that the two forces have to be the same magnitude, the same line of action, and an opposite sense. So the two forces have to be equal and opposite for that to be in equilibrium. Otherwise, something's moving or coming to equilibrium. But so let's look at some examples of this. Let's say we have this machine over here on the left, and we're going to apply, let's say this is a handle, and I'm going to pull on it in this direction. And when I pull on that in that direction, then when I look at this attached member, and I can draw a free body diagram of it, of this member here, then I have forces applied to it only in two directions, at two locations. So here's this member, and it's one piece, and we'll have a force applied at this joint here and at this joint here would be the reaction. But we know that if that happens, the only way for that to be true is if they have the same magnitude and the same line of action. So the same line of action here, but then they'll have the opposite sense. So if we pull on that, the first member, it will load this second member only at two locations, the two places where it's attached, and there's no other forces applied to it. So we know that the reactions here have to be, or the forces here have to be the same magnitude and the same line of action, but the opposite direction. And then any truss member, when we talk about a truss, we only load trusses at the joints. So if we're only loading a truss at a joint and we're not loading it within the member, then every truss member is a two-force member. And we know then, and we can look at the geometry of it, if we take, let's say, a free body diagram of this member right here, and I draw a free body diagram of that member, then I know the only way that this is possible is if the forces on either end of it are equal and opposite, and we know that it has to be directed along that member, and so that helps us a lot when we're trying to solve this. So this force would be equal and opposite to this force. And this would be shown in tension. It could also be compression. We show compression as pushing on it. My last little example here, so we have this frame, and if I load it here in the middle, this member that I'm loading would have force applied at the joints, and so there's those uprights are not two-force members. They have at least three. But when I look at this crossbar here, right here, this piece, and I take that out, and I draw a free body diagram of that, then I know that the only way this is in equilibrium is if those forces on either end of it, because it's a two-force member, that these are equal and opposite to each other. I could probably make this one the positive, and this one should probably be the negative one, but they're really the same, and the direction on them shows that. So the magnitude of them would be the same, and they have the same line of action, and they would have the opposite sense. So hopefully that helps a little with two-force members.